Hi students, have a nice day. In this section we are going to discuss about the Hess law, then some other important enthalpy changes like enthalpy of solution, hydration enthalpy, lattice enthalpy. First of all, we discuss Hess law. Hess law is also known as law of constant heat summation. Okay, Hess law of constant heat summation. Hess law states that the enthalpy change for a reaction is same whether the reaction takes place in a single step or several steps. Once again, Hess law states that the enthalpy change for a reaction, for a chemical reaction, is same whether the reaction is taking place in one step or in a single step or several steps. Okay, so let's take one general example. Here we consider a reaction takes place, reactants A to D, and the enthalpy of formation of compound is delta F, subscript F, H naught is equal to, you take it is X kilojoule per mole. Okay, here we consider a reaction A to D. Okay, A to D, the formation enthalpy is take X kilojoule per mole. And also this same reaction is taking place in different steps, several steps. A is converted into D, it is formation enthalpy, okay, H naught. And first the A is converted into B. In another path, A is converted into B. The enthalpy change, enthalpy R H naught of a reaction is, you take, it is Y kilojoule per mole. Y kilojoule per mole. Okay. Then when the B is changed into C, the enthalpy of reaction H naught is, you take, it is Z kilojoule per mole. Okay. And finally the C is converted into D. C is converted into D. You take the enthalpy of reaction H naught is equal to W kilojoule per mole. Or you can take this as a W, Y, X, Y, Z. No problem. Then according to Hess law states that the enthalpy change is same whether the reaction takes place in a single step or several steps. So enthalpy of formation of D is equal to, enthalpy of formation of D is equal to enthalpy of reaction of A to B, that is Y kilojoule, plus, or we have to write enthalpy of formation of H naught in the first step. Okay, this is second step, this is third step. First step, second step, third step. Okay, so RH1 plus delta RH2 plus delta RH3. Also we can write that this is X. So X kilojoule per mole is equal to Y kilojoule per mole plus Z kilojoule per mole plus W kilojoule per mole. This is stated by Hess law. Okay, Hess states that the enthalpy of a reaction is same whether it takes place in a single step or in a several steps. Okay, മലയാളത്തിലൊന്ന് പറയാം, ഒരു റിയാക്ഷന്റെ എൻതാൽപ്പി ചേഞ്ച് എന്ന് പറഞ്ഞാൽ ആ റിയാക്ഷൻ ഒരു സ്റ്റെപ്പിൽ നടന്നാലും different steps നടന്നാലും same ആയിരിക്കും. അതാണ് അതിന്റെ മലയാളം. Okay. Then let's do one example. Okay, we have to prove one example. Let's take the formation of carbon dioxide. Okay, I'll just erase this. The formation of carbon dioxide is taken as an example. C graphite plus O2 gas gives CO2 gas. The enthalpy of reaction, the enthalpy of formation of reaction is equal to minus 393.5 kilojoule per mole. Are you clear? Carbon plus O2 gives carbon dioxide. The enthalpy of formation is minus 393.5 kilojoule. Okay, this takes place in a single step. Next, the reaction is taking place in two steps. What happens? We have to check it. C graphite plus half O2 gas gives CO gas. Okay, the enthalpy of formation of carbon monoxide is equal to minus 110.5 kilojoule per mole. Minus 110 kilojoule per mole. And in the second step, this intermediate carbon monoxide gas plus half O2 gas gives carbon dioxide gas. The enthalpy of formation of reaction, okay, the enthalpy of formation of the compound is equal to minus 283 kilojoule per mole. Okay, minus 283 kilojoule per mole. What about the overall reaction? Overall reaction, by adding these two, the left side C graphite. Okay, C graphite. Then half O2 plus half O2, O2 gas. Okay, half oxygen here, half oxygen here. So one oxygen, O2 gas. And carbon monoxide gas in the right side, carbon monoxide gas in the left side. So by adding these two are cancelled. Okay. When an equation is added, the common factors in the left and right hand side we have to remove. Then gives in the right hand side CO2 gas. According to thermochemical equation, when we add to thermochemical equation, the enthalpy change also added. Okay. When we subtract two equation, the enthalpy change also subtracted. So here we add these two equations. So we have to add the enthalpy change also. You add it. Okay. 0.5. Then 3 plus 0, 3. 8 plus 1, 9. 2 plus 1, 3. So minus 283 plus minus 110 kilojoule is equal to minus 383.5. Hess law is proved. Okay, the Hess law can be proved by taking carbon dioxide formation. Carbon dioxide formed in a single step, enthalpy change is minus 393.5. Carbon dioxide formed in two steps. Okay, the enthalpy change is same. The enthalpy change is same. That's about the Hess law. Okay, Hess law states that the enthalpy change for a reaction is same whether the reaction takes place in a single step or several steps. Okay, let's move to the applications of Hess law. First application, determination of enthalpy of reaction. Determination of enthalpy of reaction. Second one is determination of enthalpy of formation. Okay, determination of enthalpy of formation. Next is determination of enthalpy of transformation or phase transition. determination of enthalpy of transformation or phase transition. And the next is determination of bond enthalpies. Okay, we have to determine the bond enthalpies. And one more is determination of lattice enthalpy. Okay, so these are the different applications of Hess laws. Okay, then next we move to the hydration enthalpy. What is hydration? Hydra means water. Okay, hydra means water. So hydration enthalpy is the enthalpy change when 1 mole of a substance is hydrated. Okay, when 1 mole of substance is hydrated, it is called enthalpy of hydration. For example, in the case of NaCl, the enthalpy of hydration is minus 784 kilojoule. Okay, enthalpy of hydration. The enthalpy change accompanying when 1 mole of substance is hydrated. Hydrated means the substance is surrounded by water molecule. Okay, let's take one example. NaCl solid plus water H2 gives Na plus aqueous plus Cl minus aqueous. And this is called enthalpy of hydration delta H naught. For NaCl, it is minus 784 kilojoule per mole. Are you clear about the enthalpy of hydration? It is not in the definition, is not in the textbook. The enthalpy change accompanying when 1 mole of a substance or ion is hydrated. Okay, hydrated means the molecule or the ions is surrounded by water molecule. Okay, then enthalpy of solvation means if we take any solvents instead of water, the other solvents, it is called enthalpy of solvation. Okay, alcohol is a solvent, ether is a solvent. So when water is considered, the enthalpy change is called enthalpy of hydration. Generally we can say that enthalpy of solvation. The solvent molecule is surrounded by the substance. Okay. Then next is enthalpy of solution. Okay. The first one is enthalpy of hydration. And the second one is enthalpy of solution. Enthalpy of solution. What is enthalpy of solution? Enthalpy of solution means, okay, the enthalpy of solution means the enthalpy change accompanying when 1 mole of a solid substance is dissolved in a specified amount of solvent. Okay, once again, the enthalpy change accompanying when 1 mole of a solid substance, okay, 1 mole of a solid compound is dissolved in a specified amount of solvent. Okay, that is called enthalpy of dissolution. Okay, once again we consider the same. NaCl, okay, NaCl is taken, or we have to take general equation AB solid. Okay, AB solid plus H2. Now we consider H2 as a solvent. H2 gives A plus aqueous plus B minus aqueous. Okay, then the process is take place in 2 steps. let's consider first of all A plus gas plus B minus gas. It is called a lattice enthalpy. Okay, delta lattice enthalpy. Lattice enthalpy. We will discuss just now. Okay, lattice enthalpy. And then the water molecule is added. Okay, water molecule is added. That is called a hydration enthalpy. So delta HYD, hydration enthalpy, that gives A plus aqueous. It is delta solution enthalpy. This is dissolution. Solid substance is dissolved in the liquid. Specified amount of solvent is called a solvation enthalpy or enthalpy of solution. Not a solvation enthalpy, enthalpy of solution. Okay. Solvation enthalpy is when 1 mole of substance is solvated. Hydrated means hydration enthalpy. Okay. A very simple concept. This is also according to the Hess law. So according to Hess law, we have to write that delta SOL H naught. Enthalpy of solution, enthalpy of dissolution is equal to lattice enthalpy plus hydration enthalpy. Okay, lattice enthalpy plus hydration enthalpy. Once again I explain. Enthalpy of a solution means the enthalpy change accompanying or enthalpy change occurs when 1 mole of solid is dissolved in the specified amount of solvent. Okay, specified amount of solvent. So here we take one example, AB solid. Let's take NaCl. Okay, NaCl solid plus water. Okay, so dissolved in a specified amount of water. Enthalpy of solution. Okay, enthalpy of solution delta Sol H naught. A plus aqueous plus B minus aqueous. Then here the reaction takes place in a 2 steps. You suppose the reaction takes place in a 2 steps. First of all, AB solid is converted into A plus gas plus B minus gas. It is lattice enthalpy. Okay, lattice enthalpy delta lattice H naught. Then only hydration takes place. So hydration means hydration. Okay, hydrated. The ions or compounds are hydrated. So delta hydration enthalpy will lead to the formation of A plus aqueous plus B minus aqueous. According to Hess law, this reaction takes place in a single step. This takes place in a 2 steps. Okay, so delta solution is equal to lattice enthalpy plus hydration enthalpy. Okay, and remember that most of the ionic substance is soluble in water. Okay, most of the ionic substance soluble in water by heating, by absorbing heat. And that's why we can say that most of the dissolutions are endothermic. Okay, most of the dissolutions are endothermic. Some rare reactions are exothermic. For example, dissolution of NaOH solid. Heat is liberated. Okay, heat is liberated. So very rare case, the enthalpy of solution is negative. Usually or mostly the enthalpy of a solution is positive. That is, the enthalpy is positive means endothermic reaction. We must heat the solution to dissolve the solid in the particular amount of solvent. Okay, we heat the substance to dissolve the solvent. For example, NaCl is easily soluble in hot water than the cold water. Similarly, you know that sugar is easily soluble in hot water than the cold water. Okay, you can take one example. Sugar added to hot tea, it is easily dissolved. Into cold coffee or tea, it takes some time. Okay, sugar is added to hot tea or coffee, it is easily dissolved. That means the dissolution of sugar, NaCl, etc. are endothermic reaction by absorbing heat energy. Okay, so that's about the enthalpy of hydration and enthalpy of solution.